I get it, you are staring at a stack of memory specs and wondering if splurging on a 256GB kit is going to actually move the needle for your server, or if you're just loading up a pricey brick that will sit idle most of the time. You've probably already heard the hype about more RAM means faster performance, but you also know there's a real risk of buying something that isn't compatible, or that you'll never really need. That hesitation is exactly why I dug into the details before hitting record, and why I'm talking about the practical side of this OWC 256GB DDR4 ECC RDIMM kit instead of just rattling off the numbers. Link is in the description if you want to check the product details on Amazon. First off, let's set the scene. This isn't a gaming upgrade or a laptop memory boost. It's a pair of 128GB modules, ECC registered DIMMs built for the kind of workloads you see in data centers, virtualization farms, and high-throughput database servers. If you've ever tried to run several virtual machines on a single host, or you're managing a SQL server that eats gigabytes of cache daily, you'll know that hitting the memory ceiling forces the OS to start swapping to disk, which can turn a smooth operation into a lag monster. That's the core problem this kit is designed to solve, keeping your critical workloads in RAM where they belong. Now, who actually benefits from a 256GB ECC upgrade? Think of small to medium businesses that run multiple services on a single physical server, remote work environments that need to host a few virtual desktops, or engineers who develop AI models that require large tensors. In those scenarios, the extra capacity lets you keep more active datasets in memory, reduces latency, and eliminates the dreaded out-of-memory errors that can crash services. Because the modules are ECC, error-correcting code, and registered, they also add a layer of data integrity. The error correction catches single-bit flips before they corrupt your files, a tiny safety net that can be a lifesaver when you're dealing with financial transactions or scientific calculations where a single corrupted bit could mean a costly mistake. On the flip side, if you're a typical home user, a gamer, or even a content creator who runs Photoshop on a desktop, you probably don't need ECC or that much capacity. Most consumer motherboards won't even accept registered DIMMs, and the cost per gigabyte is substantially higher than standard non-ECC sticks. In those cases, you'd be better off spending that budget on a faster CPU or a better GPU. The same goes for legacy servers that only support 2Rx8 modules. They simply won't recognize a 4Rx4 configuration, which is what you get with this OWC kit. So the first practical trade-off is compatibility. You need a motherboard and BIOS that explicitly lists support for DDR4 2933MHz ECC registered DIMMs, and you need to verify that the slot layout can handle the 4-rank design. Assuming you've checked that, the next thing to consider is how the kit actually behaves under load. In real-world terms, the ECC feature constantly monitors each memory word for errors, correcting them on the fly. That adds a tiny amount of latency, typically a few nanoseconds, but the trade-off is negligible compared to the risk of an undetected bit flip. For most server workloads, that latency is invisible, and the stability gain is worth it. The registered nature of these modules also reduces the electrical load on the memory controller, which means you can safely populate all the DIMM slots on a high-density board without worrying about signal integrity issues. That's why you see this kind of memory in enterprise racks where uptime is a non-negotiable metric. One practical strength that isn't always obvious from the spec sheet is the future-proofing factor. A lot of servers are purchased with an eye toward growth, and buying a 256GB upgrade now can spare you a later downtime window for a second upgrade. In environments where you run virtual machines that are constantly being spun up for testing or development, having that extra headroom can cut the time you spend juggling resources. It also means you can consolidate workloads, run a backup server and a primary application server on the same box without constantly hitting the memory ceiling. The downside, beyond the compatibility check, is the price point. ECC registered memory carries a premium because of the additional chips needed for error correction and the registration buffer. If your workload only occasionally brushes the 128GB mark, you might be over-investing. In that scenario, a smaller ECC kit, say 64GB, could give you the safety net you need without the extra cost. Another subtle trade-off is power consumption. Registered DIMMs draw a bit more power than unbuffered modules, which can matter if you're running a densely packed rack where every watt counts toward your cooling budget. It's not a deal breaker, but it's something to factor into your total cost of ownership. So how does the OWC brand fit into all this? OWC has built a reputation among Mac upgrade circles and niche workstation builders for delivering memory that meets strict compliance standards. The 100% compliant claim means these modules have